everyone, today we're going to solve linear systems using substitution. In my last video lesson, I showed you how you can solve linear systems by graphing, but today we're going to be learning about substitution, which is one of the algebraic techniques that you can use. Elimination is also an algebraic technique, and I will cover that in my next video. So why do we want to use algebraic methods, right? The reason why is because when we're graphing, it's not always accurate, right? And if you recall, even in my last video, all of the points of intersections that we had, they were whole numbers, right? Like 3, 4, 2, 6, 1, 2. These are all whole numbers. So you can guess these off of a graph, right? But when you have, let's say, fractions or decimals, you can't always estimate those just by looking off of a graph, right? So if the coordinate is like this, 1 over 12, negative 3 over 14, there is no way you can guess this value off of a graph, right? So that's why we want to use algebra, because the only way we can find the exact value is through algebraic techniques, and that's what we need. So from my previous lesson, if you recall, this was a major concept, and that's linear systems can have no solutions, one solution, or an infinite number of solutions. So you want to keep this in mind because this is going to make your life very easy in this unit, and you'll see how later on as we progress. But if a linear system has one solution, your slopes are going to be different and your intercepts will also be different. So visually, it's going to be something like this, not exactly, but you're going to have two lines that are going in opposite directions and they intersect at a point, and the x and y value of that point is the solution. That's what you're solving for. You're going to have no solutions when your slopes are the same and your intercepts are different. So visually, you're going to have two lines that are going in the same direction because their slope is the same, but their intercepts are different, and so they're going to be parallel and distinct. And so these lines are going to go on forever like this, and they're never going to intersect, hence why we have no solution. And infinite solutions happen when your slope are the same and your intercepts are also the same. So in this case, your lines are going to be the exact same, right? Because the slope is the same and the y-intercept is also the same. And so they intersect infinitely at every single point because they lie right on top of each other. And mathematically, we say that these lines are parallel and coincident. So that's something you need to keep in mind. So here I have some steps for you that I want you to keep in mind when you're solving for these. So what you want to do is you want to rearrange an equation to isolate for x or y. So sometimes it's easier to isolate for one, it depends, but that's what you want to do. Then you're going to substitute what the isolated variable is equal to into the other equation. So if I isolate for y, so let's say y is equal to a bunch of this stuff, right? This is what we're going to sub into the other equation. So we're going to sub this into this y right here. Whatever this y is equal to goes into that y. I hope that makes sense. If it doesn't, don't worry, we're going to go over a lot of examples so you get used to it. So once you substitute that, you're going to solve the new equation for the other variable, and you're going to plug that answer back into the original equation and solve for the other variable. So you can also check your answer using the left-hand side, right-hand side check, and that's very helpful on a test or a quiz because then you'll know whether your answer is right or not. So let's get started with some examples. So here I've given you two different linear equations. So we have 5x minus 3y minus 2 equals 0 and 7x plus y equals 0. The first step is to rearrange the equation to isolate for a variable. So if we take a look at equation number 1, we have x and y, but both of them have a coefficient, right? So they both are kind of complicated. Like this is a little bit, I don't like this, right? Let's take a look at the second equation. So we have x and y. We have a 7 in front of this x, but if you take a look at this y, it has nothing, right? Its coefficient is 1. So we can isolate for this. So let me call this equation 1 and equation 2. So I can say y is equal to negative 7x, right? So I just move this over to this side, and there I isolated for y, right? When you're isolating for a variable, you want that variable on its own, equal to whatever else, right? That's all that means. So now we isolated for y. So what do? We sub in whatever the y is equal to into the other equation for the variable. So y is equal to this, and this substitutes into this y. So what do you get? You get 5x minus 3 times what this y is equal to, which is negative 7x minus 2 equals 0. So copy the second equation down completely, but just substitute the y for what you isolated it for. I hope that makes sense. Can be a little confusing, but don't worry. The more you practice, the more you'll get used to it and you'll see it. So now you just simplify and you solve this equation, right? So 5x plus 21x minus 2 equals 0. And now do you see how we don't have a y anymore? We only have x's, which is what we want. We want to have the same variable in the equation so we can solve for it. So now we can solve for x. So 5 plus 21 is 26. We can move the 2 over to the other side. It becomes positive. So now x is equal to 2 over 26, which simplifies to 1 over 13. But we're not done yet, right? When we want to solve for the point of intersection, we're solving for an x and a y, right? Essentially, it's a point. So we found x, but now we need to find y. So how do we find y? Well, you can see that x is equal to 1 over 13. And if you take a look at this equation, right, which we got from our first one where we isolated y, we can just sub this x into here and get y. So this is x now, and then what we can do is we can just sub it into that x, and then we can compute for y. So this is step 1, this is step 2. So y is equal to negative 7 times x, which is 1 over 13, and now we can easily just solve for y, which is negative 7 over 13. See? So therefore, the point of intersection is x, which is 1 over 13, and y, which is negative 7 over 13. And as you know, there's no way we could possibly graph for this, right? It just wouldn't be accurate. So taking a look at the next example, we're given two equations once again. So we have y is equal to 5x plus 2, and then we have 2x minus 3y equals negative 16. So our first step is to isolate for x or y. So we want to see which case is easier. So let's take a look at our equation. So we have y is equal to 5x plus 2. And if you notice, y is already isolated, right? Because we have y on its own and it's equal to this. So we don't even have to isolate for x or y. It's already done for us. So I'm just going to copy that down. And now we want to sub that into our second equation. So start by copying the second equation down. 2x minus 3y equals negative 16. And now what we're going to do is we're going to take this and put this there. So we're going to take what y is equal to in the first equation and replace it in our second equation. So we get 2x minus 3 times y, which is 5x plus 2, equals negative 16. So now we're going to simplify. 2x minus 15x minus 6 is equal to negative 16. So now if you look, we don't have any y's anymore, we have only x's, which is what we want, right? We only want one variable. So here we have negative 13x is equal to negative 10. So x here is equal to x is going to be positive 10 over 13, because we have negative 10 divided by negative 13. So we found our we found our x value for our point of intersection, right? Because our point of intersection has a x and a y value, and we found x. So now we want to find y, and how are we going to find the y value? We're going to use the x value and we're going to sub that into the original equation, this first one, for x. So we're going to take this like that. So we're going to sub this 10 over 13 into this x right here, and then solve for y. So we get y is equal to 5 times x. What is x? 10 over 13. So we're going to substitute and then just copy the original equation and replace x with what it's equal to. And now we can simplify and solve. So we get 50 over 13 plus 2. So now you have to be good at adding fractions, right? If you don't have a calculator. So 50 over 13 plus 2. I want to make this 13 over 13. So what do we get? 50 plus 26 over 13. So our y is equal to 76 over 13. So therefore, the point of intersection is it? So x is 10 over 13 and y is 76 over 13. So we just solved for the point of intersection for these two equations. So now the third example here, so we have 2x plus 2y equals 7, which is equation 1, and then x plus y is equal to 6, which I'm going to call equation 2. So what is our first step? We want to isolate for x or y. And we want to take a look at what equation is easier to do that. So equation 1, we have 2x plus 2y. So I have a coefficient of 2 in front of my x, and I have a coefficient of 2 in front of my y, right? I don't like that because it's always best to have x or y have a 1 as the coefficient. It just makes your life easier. So now if I take a look at the second equation, I have a 1 in front of my x and a 1 in front of my y. So I don't have any coefficients greater than 1, right? I don't have like a 3 or a 4, I just have 1. So it's easier to isolate for x or y in this equation. Now you can isolate for x or you can isolate for y, it doesn't matter. I'm going to isolate for y. So then I'll get y is equal to 6 minus x. If you decided to isolate for x, then you would get x is equal to 6 minus y. It doesn't matter, it's up to you. So now that we've isolated for y, we're going to copy down the second equation, which is 2x plus 2y, so our other equation. And then what are we going to do? We're going to sub what y is equal to into the second equation's y. So we're going to take this and we're going to put it there. So we have 2x plus 2. What is y? Y is 6 minus x. So now we can simplify this, so we get 2x plus 12 minus 2x is equal to 7. As you can see, we do not have a y anymore. We only have x's, which is good. So now, we get 2x minus 2x is equal to 7 minus 12. And now, 2x minus 2x, this cancels, and this is 0, and this is negative 5. So 0 equals negative 5? Does this make any sense? No, it doesn't. How can 0 equal negative 5? Our x got cancelled. So if you come across a situation like this where you get 0 is equal to a number, that means you have no solution. You have no point of intersection, right? No point of intersection. And I didn't compare the slopes and the y-intercepts, right? But let's do that. So if I rearrange equation 1 to the slope y-intercept form, I will get y is equal to negative x plus 7 over 2. And then this one is going to be y is equal to negative x plus 6. So what I did here is I took the first equation and I rewrote it in the form of y is equal to mx plus b, right? So isolating for y gives me this. Y is equal to negative x plus 7 over 2. And the second equation, if I isolate for y, I get negative x plus 6, which is the same thing as 6 minus x. I just wrote the x first. So if we look here, isn't our slope the same, right? M is equal to negative 1, but our y-intercepts are different. So what situation is that? Well, slopes are the same, y-intercepts are different. So what are these lines? They're parallel and distinct. So this is the situation we have. That's why we didn't get a point of intersection, and that's why we got 0 is equal to some number, which is wrong. This makes no sense. So this is a situation where you would have no solution. Let's take a look at the last one. So this is the first equation. Let's call it the first equation. This is the second one. So 3x plus 4y is equal to 2. 6x plus 8y is equal to 4. So now looking at this, I don't think it's easier to solve for x or y in either, right? Because this has a 3, this has a 4, this has a 6, 8. Like none of them have 1 as their coefficient, right? We have numbers. So I'm just going to choose the first one. So what's our first step? Let me write this down. Isolate for x. or y. So I'm going to choose equation 1. So 3x plus 4y is equal to 2. And I'm going to isolate for y. So I'm going to move this over to that side. So I will get 4y is equal to negative 3x plus 2. And then I'm going to divide everything by 4 to isolate for y. So I will get y is equal to negative 3 over 4x plus 1/2. So now I've isolated for y. Y is equal to negative 3 over 4x plus 2. So the first step is done. Second step, copy down the other equation. So 6x plus 8y is equal to 4. And now what do? We take what this y is equal to and we put it here for this y. Let's say if we chose to isolate for x, right? So let's say if I did 3x is equal to 2 minus 4y, divide everything by 3. So I would get x is equal to negative 4 over 3y plus 2 over 3. If I isolate for x, then I sub this part. So I would sub the negative 4 over 3y plus the 2 over 3. I would sub that portion into x. Okay, but because it's y, we sub it into y. So we would get 6x plus 8 times, what is y equal to? Negative 3 over 4x plus 1/2. And that is equal to 4. So now we can simplify. We get 6x minus 24 over 4x plus 8 over 2, which is equal to 4. So now 24 divided by 4 is 6. So we get this. 8 divided by 2 is also 4. So now let's move this 4 over to the side because we want to have the x's on one side. So I get 6x minus 6x is equal to 4 minus 4. So this cancels, this is equal to 0, and 4 minus 4 is also equal to 0. So now what? Now we don't have x, right? Our x canceled out. So in this first situation, we had 0 is equal to any number. So we also had 0 is equal to 0. But 0 is equal to 0 makes sense, right? Because 0 is 0. Like, that makes sense. Like 0 cannot be equal to, let's say, 1, or 0 cannot be equal to 2, but 0 can be equal to 0, right? Because this is true. So it's not like we have no solutions. We do have a solution, but we have an infinite number of solutions. Okay, so we have an infinite number of solutions. So whenever you're doing substitution and you get 0 is equal to 0, that's your sign that you have an infinite number of solutions. And so let's isolate, not isolate, but let's rearrange these equations to the slope y-intercept form and see. So here, equation 1, we have 4y is equal to negative 3x plus 2. Divide everything by 4. We will get y is equal to negative 3 over 4x plus 2 over 4. Because our lines should be the same, right? If we have an infinite number of solutions, what this means is that our lines are the same lines, and they intersect at an infinite number of points, right? Like if you look here, we have the same slope and the same y-intercept. So let's check that and see. So equation number 2 now, let's isolate for y. So we get 4, and now let's divide everything by 8. So we get y is equal to negative 6 over 8x plus 4 over 8. And now let's simplify this a little bit further. So this is y is equal to negative 3 over 4x plus 1/2. And this is also y is equal to negative 3 over 4x plus 1/2. And oh my god, look at this. They're the same equation, right? Same slope, negative 3 over 4, and same y-intercept, which is 1/2. So mathematically, it makes sense that we got 0 equals to 0 because we have an infinite number of solutions. So those are the 3 different cases that you're going to come across when you're using substitution. You will either get a point of intersection, so you'll either get an x or a y value, or you will get some weird situation where your x will cancel and either you will have 0 is equal to any number, or you will get 0 is equal to 0. And so now you know if you have 0 equals to 0, you have an infinite number of solutions, and if you have 0 is equal to some random number that's not 0, you have no solution.